Welcome everyone to this final event of the SafeWAVE project. My name is Lotta Pittima. I'm the coordinator of ETIP Ocean that is hosting this event. And the purpose of ETIP Ocean is indeed to share knowledge and enable exchanges across the ocean energy sector. So we are very happy to be able to amplify the outreach of SafeWAVE and bring this webinar to all of you today. And I have personally been waiting to hear the results of the project because a better understanding of the environmental impact of ocean energy and also of the challenges in consenting will tremendously help unlock new deployments and ensure that the sector grows in harmony with the environment. And this is exactly what the SafeWAVE project has been focusing on. So I really look forward to a very interesting event. Before handing over to the SafeWAVE team here, let me remind you that this event is recorded and you'll find the recording both on the ETIP Ocean website and the SafeWAVE websites, together with all the presentations. If you have any questions throughout the event, please make sure to write them in the Q&A box, so they will be easier to pick up from there. For any other remarks or sharing of information that don't necessarily require an answer, please use the chat for that. So without further ado, I'd like to give the floor to the coordinator of SafeWAVE, Juan Bald from ASTI.
Hello. Thank you, Lotta. Let me share my screen. Okay. Okay, do you see my screen correctly?
Yes.
Yes?
Yes.
Okay. So thank you. Thank you very much, Lotta. Thank you very much for hosting this session and giving the opportunity to the SafeWAVE project team to present in this final event, the results of the project. Thank you to ETIP Ocean for hosting. And yes, my name is Juan Bald. I am the head of the Marine and Coastal Environmental Management Unit of ASTI in the Basque Country, and I am the general coordinator of the SafeWAVE project. And I would like to welcome all of you for your interest in this project that we will present during this 1 hour and a half that we have behind us. Well, some technical aspects yet explained by Lotta. You have the Q&A chat for questions that will be responded during all the sessions. You can pose your questions whenever you want. And you have also a general chat if you want to share any relevant information or any comment. And you realize that you have muted because if not, it's very difficult to manage the session. But go to the Q&A chat and then put your question and it will be responded. So this is the agenda. As you can see, this agenda. We will starting with this introduction to the SafeWAVE project, a general introduction to the SafeWAVE project. And then I will give room to 4 of my colleagues of the consortium to explain the main research strategies that we have developed in this project. And I will finish with some final remarks and conclusion at the end of the session. Okay, SafeWAVE. The SafeWAVE project is the continuation of another one, which was called WESE project. Both projects share similar objectives, and both were funded by the European Union, by the SINEA agency. SafeWAVE started in 2020 and will end this year in December 2024. So we are very close to the end of the project, finalizing the last deliverables that will be available in the SafeWAVE project. So if you want to go deeper on the results of the project, because we don't have so much time to explain 3 years project, you can go to the SafeWAVE web page, and then you will find the deliverables with deeper information of what we are going to explain today. So in this consortium, we have 2 two groups, scientific partners and industrial partners. In the scientific side, we have ASTI from the Basque Country in Spain, together with CTN of Cartagena, also in Spain, WEBEC and Hidromod in Portugal, École Centrale de Nantes and OpenSea Foundation in France, and UCC Marais in Ireland. And we have these industrial partners that are very, very, very important in this project, because behind it, in this site, we have two developers, Techno and Power Ocean. We have the test site of BMEP in the Basque Country, the Sky Marine Energy Platform, and RTCs from France. Okay, so the context, as you know, the technological development of the wave energy devices is growing fast, but we have still some non-technological barriers that can put in difficulties the development in the future of this industry. These are the environmental risk and uncertainty that we have about the environmental impacts of these developments. We need marine spatial planning approach for site selection to overcome this potential competition of this industry with other marine users. We have these complex and long consenting procedures. And finally, the potential opposition of the host communities to these deployments. So it was the aim of the project to contribute to overcoming these barriers through three specific strategies. First one, the environmental research and demonstration strategy, a consenting and planning strategy, and a public education and engagement strategy. Regarding the first one, environmental research, it was based on the collection, processing, modeling, analysis, and sharing of all the environmental data that we have collected around real devices operating in real conditions in different countries, in Spain, France, and Portugal. We have focused on the monitoring of underwater noise, shipper integrity, and electromagnetic fields. And with this data, we have tried to modelize the underwater noise propagation, the electromagnetic fields propagation, and the impact over marine dynamics of this harnessing of energy coming from harnessing of the energy of the waves. And all this information has been shared through a specific and dedicated data platform, which name is Marine Data, and that has been developed by Hidromod. Regarding the consenting and planning strategy, we have developed guidance to ocean energy developers and public authorities in charge of these consenting procedures. These guidance were developed in the WESE project for Spain and Portugal, and now we have developed this guidance for France and Ireland. And same with the marine spatial planning, we have developed marine spatial planning support tools that were developed for Spain and Portugal, and now we have extended to France and Ireland. So we have these tools operating in all the Atlantic arc. And finally, regarding the public education and engagement strategy, we have developed EPA programs for public education, trying to overcome this perception, perhaps this negative perception of the public about these future deployments of wave energy. And we have tested these programs in different countries, as we will see later on. So who can benefit from this project? In general, we consider that academic, regulators, developers, and public in general, because we provide a better knowledge of these real environmental impacts. We provide decision support tools for the site identification. We provide guidelines for environmental consenting, and we have developed EPA programs for public education and engagement. So these are the who can benefit from this project. So now, after this very brief and general introduction, to the SafeWAVE project, I will give room to 4 of my colleagues that will explain in more detail these research strategies. First of all, my colleague Pedro Vinagre from WAVEC in Portugal, he will explain the environmental research and demonstration strategy. Afterwards, Yvonne Galpasoro from ASTI in the Basque Country and Emma Berlin from UCC Marey will explain the consenting and planning strategy. And finally, Niall Dunphy from UCC Marey will explain us the public education and engagement strategy. And at the end, I will finish myself with some final remarks and conclusions. So now, that's all, and I will give room to my colleague Pedro. So I stop sharing my screen and give you the room, okay?
I'm not able to share yet, Juan. Okay, now I can. Please confirm that you can hear me.
We hear you, but we don't see your presentation.
And let's see. Can you see my presentation?
It's coming. Yes, now it's okay.
Okay, thank you. Hello, everyone. Good morning or good afternoon. Thank you all for attending this final event of Project SafeWAVE. I apologize for not showing my face, but I'm having issues with the video. My name is Pedro Vinagre. I'm a senior researcher at WAVEC Offshore Renewables, and today I'm presenting the Project SafeWAVE's environmental research demonstration strategy. Juan already showed this very briefly, but the aim of this strategy was to collect, process, model, analyze, and share data which was collected around 4 different wave energy technologies at different test sites. And this was a tight effort between many researchers in the consortium from different partners, and included work among or across 3 work packages. So essentially, we acquired data on underwater noise. We monitored seafloor integrity, electromagnetic fields, and fish communities. Modeling was undertaken for underwater noise propagation or sound propagation, electromagnetic fields, and marine dynamics. And all the data, as Juan already said, is being shared through the Marin data portal. This is just an overview of the different technologies and test sites. From the left to the right, you have the Motrico Wave Power Plant in Motrico, Spain, the Penguin 2 of Wello in BMAP, Spain, iWave of Core Power Ocean in Aguçadora, Portugal, and the Wave Gem by GAPS Techno in SafeWAVE, France. In the final column, you have the topics that were foreseen to be addressed for all of these technologies. Not all of them were completed, but I advise you to check all the details in the deliverables that are uploaded into the Project SafeWAVE website. So without further delays, let's move on for our achievements. Regarding the acoustic monitoring and modeling, we were able to gather inputs from all test sites, which provided a good modeling with good resolution. We were able to do successful campaigns using 3 hydrophones at increasing distances from the WECs. And in some cases, we could include seasonality by obtaining 1-year data. We modeled 3 frequencies, namely the first 2, which are the recommended by the Marine Strategy Framework Directive, and we added an additional 1. I'm providing an example for the SafeWAVE test site. And so this is the result from the acoustic disturbance area metrics. You can see that the sound propagation levels are different according to the frequency that is monitored. But what the main take on here is that you have an inner blue contour. I don't know if I can use a pointer. Yeah, I can. So you have this inner contour here, which essentially is the noise, is the area of the noise being generated by the WEC. And then you have a black one here outside, which is the background noise that can be audible to low frequency cetaceans. And so essentially what you can see from here is that the area where noise is reaching or being audible to low frequency cetaceans, noise coming from the WEC is much smaller than the background noise. However, as you can see also there, very close to the WEC, some sound pressure level in decibels are very large, sometimes even overpassing the 100, 120 decibels, which is reaching the thresholds named in the standards or in the guidelines as potentially posing some responses in terms of biology or even physiology of these organisms. Just to mention that these ranges or the distance at which the noise can reach depends a lot on the frequency, depends a lot on the wave height, and also on the season. And also when modeling one device, the area is much smaller than when modeling an array of devices, for example. So regarding the electromagnetic field, due to industrial schedules, we were able to conduct monitoring only at the SafeWAVE. An improvement from the WESE project was that here we used an AUV instead of a boat to tow the gradiometer. Using the AUV returned very beneficial because it allowed to cover large areas and also to acquire data always at a constant height above the seafloor, which was not possible before. You can see on your right side the transects that were performed across the umbilical cable. Also, we could cover some data here on the export cable. At this time, the devices that were in the same rev, so the wave energy device, WaveJam, was not connected to the grid. So instead, we monitored another device, which was FloatGen. Here you have the magnetic signature of the data collected. And here you can see there was some fault in the methodology, and so we discarded this data. We used the modeling tool that was developed in WESE, and we improved it and we validated it. So comparing the data that was acquired in SafeWAVE and the modeling results, we obtained the same order of magnitude, which was good. This was in nanoteslas. And when we modeled, so we used the tool to model several scenarios. The most important would be when the cables or the devices are operating at rated conditions. You can see that, so here we have only examples for 10 centimeters and 3 centimeters for both magnetic and electric field from the cable. You can see there is a large decay with distance. You can also see that, well, larger values are always for the cable examples. And the overall conclusions here is that regarding the devices and well, also for the cables and specifically for the magnetic fields, impacts would not be significant, at least comparing to what is in the literature for fish and crustaceans. However, on the other hand, the electric component could be a bit more could pose greater negative effects, essentially to species that are electrosensitive. Regarding the monitoring of seafloor integrity, we used complementary techniques, namely ROV and an AUV with the side scan sonar. The side scan sonar allowed to cover a large area and monitor the seafloor morphology. And well, the main results with the ROV, we could notice an attraction of fauna and also its refuge in the moorings and also in the anchoring system. These are images from BMAP. With the side scan sonar, we could check some footprints in the seafloor. Especially, you can see in your bottom right image here, there is some footprint caused by the mooring. This area was estimated as less than 1% of the installation area, so it was deemed insignificant. However, the moorings are still there, so we are not sure about the duration of this small footprint. Regarding fish communities, this was a topic that was not covered in WESE, and here ASTI implemented two different techniques to monitor the fish communities. So these were developed in the project. One of those was the ASTI's aquatic surface vehicle. It's a drone. So the It's a drone was able to work remotely and autonomously and also covered large areas. In the first trial, its drone was used to detect fish schools before the installation of these two devices. Again, here, the device present in BMAP was decommissioned very early in the project, so there was no wave energy device there. Instead, these two devices were monitored. So in 2022, a first survey to detect fish schools before the installation of the devices, and then another survey more recently in 2024 to estimate their abundance or the abundance of fish schools as a function of distance to these devices. As you can see in these graphs, there was a significant difference in abundance between the before and after the devices were installed. And this was particularly evident in the case of the DemoSat. You can see there are more fish schools being observed, but in a lower energy, which suggests that these are smaller individuals. When I'm sorry, looking at the analysis of abundance as a function of distance to the devices, you can see, for example, in the ARCH lab, the trends are similar between before and after the device was installed. On the other hand, with the DemoSat device, the trend is inversed. So when the device is installed, here in yellow, the abundance of fish seemed to increase with the distance. This relation, however, was very small. Although it is significant, statistically significant, the relationship is very, very small. The second technique used was the WBAT, essentially an echo sounder, which was anchored to the ARCH lab device. It was able to cover a longer time series of data for 1 month, and it was used to study the temporal variation of the fish communities. The main results here are that, well, the fish abundance increased with the radiance, so essentially abundance is increasing with moving towards the summer. At both day and night times, a greater abundance was found in the first meters of the water column and the lowest at about the 40 meters depth. And no clear differences in the patterns were observed between night and day. For the Aguçador test site, fish communities was actually not foreseen in the project, but we were able to conduct now at the end of the project 2 campaigns, 2 baseline surveys. So there was yet no information about the fish communities in this area. These baseline surveys were conducted during July and November 2024. Basically, trawling in transects and pot deployment were done in 2 areas. One, an impact area around the device, and another one, a control area. Although these areas were foreseen to be very similar in terms of features, oceanographic features, we found later that the seabed was very different between these areas. In fact, this impact area is mostly medium sand, and all the areas to the north and to the south have a much wider range of sea bottoms, between fine sand and also until rock. And as you can see, this returned very different community structure between these 2 areas, where we have a control area where we found many more species, both of fish and invertebrates. We also found some relationships between certain species with these areas. Basically, we had one invertebrate, the swimming crab, which was the most frequent species, was present in all samples and with abundance. And then we had some frequent fish, such as the pouting in the control area, the wedge sole and triglyphids in the impact area, and the dragonet in both areas. We had rare fish, which were present in only 1 sample, so 1 in 10 samples, in 10 transects. And these were the Atlantic bonito, the magrim sole, and the thornback ray in the impact area, and the comber and black sea bream in the control area. So as I mentioned, these were baseline characterizations. We intend in the future to conduct several surveys to establish a better baseline, to reduce uncertainty about natural variability, and which can be later compared with operational surveys and infer on the potential effects of these projects. Regarding marine dynamics, some methodologies developed in BMAP were here used and validated. They were compared with in situ data, and well, the models are now stable and robust under different grid sizes. Different statistical downscaling methods were tested, and namely the hybrid statistical downscaling, which is proved suitable for probabilistic waveform coastal impact studies. Overall, in terms of impacts, it was found little effects of the waveform in the wave height and also in the coastline, and the changes in shoreline were below 5 meters and much heterogeneous along the beach. For the Aguçadora, a new modeling or a new model was developed in SafeWAVE. The model shows here the results for a waveform, and you can see some shadowing effect that diminishes the shore, with a reduction near shore being less than 2%. And overall, the results suggest that the waveform would not influence the sediment transport ashore or a similar process. Finally, one achievement was to improve marine data. This was done by HydroMod. So the field data that has been gathered during the project is being uploaded to the marine data. The marine data already supports information from previous projects, such as the WESE, SeaWAVE, and SOFIA. It is now able to be searchable in Primary, so is indexed in Primary. The platform supports multiple data format types, including video files, PDFs, CSV, and this can be visualized as charts, as you have here an example. User stories were added to guide the users on the platform and also expand its functionalities. And you can also download long-term wave and wind series and reports analysis. So these include data from 1979 until 2021. And you can use, well, it allows third-party identity providers, so essentially from Microsoft, Google, and other types of accounts, so that you don't need to create a new username and memorize a new password. So this was my presentation for today. I don't know if we have time, but I would like to present some of our challenges and suggestions for future work. I think I still have a few minutes, right?
Well, if you want to leave it, sometimes we have two questions, so you can
Okay, so before the questions, I just want to thank all of my colleagues that, well, I'm sorry if I forget someone, but these were the main colleagues working in these 3 work packages. You have here the contacts of myself, leader of work package 2, Ivan Felish from work package 3, José Chambel from work package 4, and of course the coordinator Juan Baldo. So thank you all to my colleagues, and let's move on to the questions then.
yeah, we have 2, but I think Juan already answered a few. One remaining perhaps is during the operation was the chain dragging around or on the seafloor, but Juan answered that moorings were fixed and not mobile, but I don't know if it's the point of the question. So perhaps did we measure some?
This one.
We observed some dragging, probably.
Yes, okay.
This one. I think the images that we have do not show that. This image here, as you can see, is basically reflecting. So this was a floating device going up and down with the tide, and in this case, it should be high tide, and so the device was at a greater height from the seafloor and lifted the mooring chain from the seafloor, leaving this footprint.
Yes, in the landing point of the chain to the seafloor, in that point, we can observe a small footprint of the interaction of the chain going down, up, down in the seafloor. Yes.
I hope it answers Arno's question. We can go on the next one. From Ian Fairley. Did you validate the modeled wave reduction? And if so, how did you measure the impact of the device on the waves?
Okay, I can maybe ask my colleagues from maybe Iñaki from Asti. I don't know if he's here, or José, someone from HydroMod.
It's about modeling, yeah.
Yeah, modeling of the marine dynamics, right?
Yes.
I don't know, you say you can go on this because you have more expertise on this in this aspect.
Or maybe directly within the chat if you can. Well, primarily the plot of Acusadora, which is the one on the bottom right, I think, of that one is that Pedro is showing. Sorry. If
You said we don't hear you.
now we can.
No, we can.
Yeah. So, well, this was done with the Swan model, and I couldn't fully understand the question.
It's on how we validated the models we use for wave reduction, I guess, or which model did we use, perhaps?
The thing is, as you saw from the data that was collected, there was no data collected in terms of waves. So in what package 2, when Pedro talked about the data, we didn't collect wave data. So, and this is a prospective analysis, so it's not possible to validate these impacts in land. Okay, so it's not it's not possible to validate. That's one of the reasons that why in the data collection there was no specifically data collection in terms of waves. Okay, so validating this is well, near shore. It would be quite a complicated thing.
I think José also is referring specifically to the work done in Aguçadora, which was done by them. But this was done by scratch, while, for example, for BMAP, in fact, these models were developed and improved. So developed in WESE, improved and validated here. So I don't think we have the person responsible for this. I think it was Iñaki. But I suppose that he can provide this answer later.
Yeah, most likely. And do we have, can we send a link to a deliverable or to the deliverable page on our website? It also answers the question about the slides. I mean, of course, I guess the slides can be made available, but there's more. I mean, what we created in SafeWAVE will be or is being published.
Yeah.
Freely available. So you can
much more.
There's much more behind what we presented today. Any other? Yeah, no worries. Any other question from the chat?
Let's see.
Or from the audience? No. And Juan answered the one from the chat on the IUV and ROV. So I think that, Pedro, we are good. And you have 1 minute left, or barely a minute left. So I don't know if you have more to add.
Okay, no, feel free to contact me if you want more details. Also, check out the deliverables. You have all the information there. You will have also 2 deliverables that will provide recommendations, guidelines, and best practices for the future. So again, I ask you to check out these deliverables in the SafeWAVE project website. And thank you all for attending.
Okay, thank you very much, Pedro. So now is room for the consenting and planning strategy. And it's room for my colleagues, Yvonne Galpasoro from ASTI and Emma Berlin from UCC Marey. So I think that, Yvonne, you are going to start talking. It's your room.
Can you see my screen now?
We see your screen, but not in presentation mode.
No. And now?
Now, yes.
Okay. So good morning or good afternoon to everyone. My name is Yvonne Galpasoro from ASTI, and I will share this presentation together with my colleague Emma Berling. So now we jump to another topic, and we will show you some synthesis of the work that we have done in terms of risk-based approaches and if they can benefit future offshore renewable energy deployment, planning, and consenting. So as it was mentioned before by Juan, main non-technological barriers for the development of wave energy converters at sea, of course, are the uncertainties regarding to the environmental impact of and impact risks of wave farms. This is basically because there are not so many examples or operational, and there are different devices, etc. So the scientific information on environmental risks is relatively low. Of course, if wave farms are going to be deployed, it will require space, and this could raise potential competition and conflicts with other marine users. And another aspect that should be considered is also the complexity of consenting processes. So taking that into account, one of the things that we conducted in the project was the identification of suitable areas for wave energy projects, considering technical, environmental, and socioeconomic risk. And when we tried to do this, we defined some requirements. So we were going to produce information that was especially explicit, that could be useful for management, for strategic environmental assessment, decision-making, consenting, or marine spatial planning. So we adopted this approach of considering the environmental risk assessment, technical risk assessment, socioeconomic risk assessment in order to produce this integrated risk assessment. So the collected data. So for environmental components, we collected 6 information layers on different ecosystem components, like fish, cephalopods, sea mammals, reptiles, birds, sensitive habitats. For technical components, we collected 7 information layers, and in this case are all the parameters that could be related to technical constraints or technical requirements for wave energy converters. And we collected 15 information layers related to the distribution of human activities at sea. So we based this work in previous research. One of them was based on the ecological risk assessment tool for wave energy converters. This is a tool that you can find in the web page. So here we had information on different types of devices, the type of pressures they can produce, and the different ecosystem elements that can be affected by those pressures. And on the other hand, we also used this model that was previously produced for Spain and the Portuguese coasts, in which we identified also suitable areas for offshore wave energy farms in a framework of ecosystem approach to marine spatial planning. So at the end, we adopted this modeling approach in which we were considering all the environmental aspects, technical aspects, potential conflicts of use, and we integrated all that into a biassembly network. So finally, that model was integrated into a decision support tool that permits the user the identification of suitable areas for offshore energy projects. And this decision support tool, it's an interface between the complex model and the GIS layers that I mentioned before. It's publicly available, and you just need a browser, and there is no need of any license, and it could be accessed in that web page. So finally, we produced 4 types of maps. First, we identified those areas that were fulfilling technical suitability conditions. So here you can see in red the distribution of those areas that were fulfilling those conditions in terms of seafloor type, depth, distance to substations, wave energy resource or potential production of energy, etc., etc., etc. In the second part, we produce this ecological risk spatial distribution, of course, as I said, based on available information. And we also produce this map of potential conflicts with existing or long-term activities and marine uses. And here we divided these conflicts into excluding activities. So, for example, all related to port infrastructures or cables or pipelines and this kind of underwater infrastructures, for example, that are incompatible with the installation of farms, but others were considered to be limiting, like, for example, fishing activity. So it could be a limiting factor for certain farms. And this is the output. This is the final results that we obtained from applying the model. And here you can see the areas that were classified as being highly suitable or suitable. And at the same time, we identified the other areas that could have certain restrictions, environmental restrictions, or any type of conflict or restriction because of marine uses. So at the first glance, what you can see is that there are certain areas which are showing high suitability, like in Ireland, Northern Ireland, in the northern France, or in the north coast of Portugal, for example. But at the same time, as we were using this spatially explicit approach, we can also estimate the amount of area that are corresponding to each of those classes. So what we can see is that the technical and environmental restrictions are more than 0.5% of the area. Then there are other areas that show different combinations of potential restrictions, but the important thing here is that we identified that 11% of the area were showing suitable or highly suitable conditions for the deployment of wave energy farms. So as final remarks, here we did the first integrated assessment to identify suitable areas in the European Atlantic region, considering the technical, environmental, and potential conflicts with maritime activities. But we have to acknowledge also here that the final selection of areas should be based on a more detailed assessment and higher resolution information layers. An important thing is that here, this model was using potential energy power production capacity. So this was incorporated due to the close collaboration with industrial partner. That means that we didn't just use the energy resource, but we computed the theoretical production capacity for a specific device. Then, as Pedro was also explaining, the reduction of uncertainty in environmental risk assessment requires more quantitative information about environmental impacts based on monitoring plans in testing sites. Of course, we need more information about socioeconomic implications and outcomes. Here we just overlapped and identified potential conflicts, but socioeconomic implications has to further studied. But what we have seen is that there is enough space in European region to achieve the estimated objectives, the objectives established by European Commission. And of course, if the space is planned properly and with caution, and in fact, those developments would fulfill industrial requirements. So this is why we try to do something and models that are based on requirements by the industry. But the definition of those areas should be made finding locations with the lowest environmental risk and limited, or if possible, no conflicts with other activities. So this was from my side, and now I give the room to Emma.
Thank you, Iban. Right, so hello everyone, I'm Emma Verling from the Maria Centre at UCC, and I'm going to present the next part of this strategy, which was work on consenting. So Iban, maybe if I ask you to change the slides as we go through. So just talking about consenting, we know this is, I suppose, another non-technological barrier to progress for wave energy devices. Consenting processes can be time consuming and they can require a lot of data. However, we do have a lot of uncertainty around the environmental impacts caused by these, so we need to take an adaptive management approach. And what this work really did was to look at risk-based approaches as part of that adaptive management. So we want to think about how we can use risk to try and speed up these consenting processes and to see if this is a feasible approach we can take. So next slide, please. Just thinking about why risk-based approaches might be useful. Well, as I said, they can speed up decision making. And importantly, they can work in data-poor situations, which is often what we're dealing with some of these new novel devices. And they can be suitable for lots of different types of scenarios, which also makes them very suitable. And they can provide a clear process, and this is an important aspect, a clear process to follow for different groups and people, so we can track how we've done this. So next slide, please. So how we arranged this work was we first of all looked at existing risk-based approaches. We know there are a lot out there. Risk-based approaches are used in many, many sectors. Not all of them are relevant to us. The number of different approaches is part of the problem, and people feel there's so much detail and so many different approaches, it's difficult to know which one to use. So we tried to summarize and simplify those relevant risk-based approaches that were out there to produce a simple sort of stepwise process that people could follow when it comes to wave energy devices. And ultimately, the aim was to produce a guidance document on a risk-based adaptive management approach. So next slide, please. So as I said, there are many different approaches, risk-based approaches out there. So what we initially did was to have a look at all the risk-based approaches that were out there and examine those and identify those ones that were most relevant. So we identified 5 particular risk-based approaches that were relevant to wave energy and offshore energy devices, and we looked at them in detail. So some of these were within academic papers. Some of them, for example, the survey, deploy, monitor one is one that's actually used in a jurisdiction which is in Scotland. So these have varying levels of complexity, and we wanted to look at those really to see what are the differences and commonalities between them. Next slide, please. So what we did really was to look, a lot of these processes involve steps, different steps, but the reality is that a lot of the work done is similar, except that they're put in different steps in the different approaches. So if you look at this kind of colourful diagram to the right, what this really shows is each of the steps in each process and the links between them. So it's showing that there are similar things being done in these different approaches. They're just being called different things, or they're being put into a different step. And you can imagine that this adds a lot to the complexity and the difficulty in understanding them. Next slide, please. So what we did then was to take these commonalities and try to come up with a simple step-by-step process. So, but also acknowledging that detail and that information that's behind all these processes. So we created 4 simple steps. And next slide, actually, Bon. So the 4 simple steps really were then shown here on the right. There's a graphic which kind of shows it in a flowchart-like way. And this is shown in one of our deliverables there that I've highlighted in the middle, deliverable 5.3. So really the idea is to show that the risk-based approach isn't really that complicated. And we can use this simple stepwise process while still acknowledging all the detail and the important academic work that's gone into it. So this stepwise approach was presented in a document. And what we did then, I suppose, was the next important part of it. Next slide, please. So what we really wanted to do was assess, well, what is the actual feasibility of using these types of risk-based approaches within certain jurisdictions? So we know that in Spain and Portugal, this was looked at already in a previous project. So this time in France and Ireland, we essentially presented this simple stepwise approach to regulators and developers in those jurisdictions. And we asked them some questions about it. So we had some workshops online and in person. We talked to them about the risk-based approach, and we asked them what they think of this approach, whether they think it's feasible, whether they think it's interesting. So this was, I suppose, some of the most interesting part of the work, because although the risk-based approach can be considered to be simple in this way, it still doesn't answer the question as to whether it's feasible. So next slide, please. So what we did was we asked them some questions. I've just listed the questions that we asked them there. This was just to frame our discussions, I suppose, asking them things like, have you used risk-based approaches? Which types of risk-based approaches have you used? Do you think these would be useful? Do you think they're feasible? So it really, we had these specific questions, but we had wide-ranging discussions in both France and Ireland about these things. And the final slide here, really, I'll talk a little bit about what came out of those discussions, because it was very interesting. I think both in France and in Ireland, neither group said they felt they were using a formalised risk-based approach in their work, but they really felt they were already considering risk concepts in an informal way. And this is very important because it means taking a risk approach is already acknowledged as being useful, but it's not structured. So there isn't a process people can follow. It's kind of, people felt it was quite an intuitive thing that they were doing anyway in much of their work. There was a really strong feeling that use of risk-based approaches has to take account of existing processes within jurisdictions. So we know that in Ireland, for example, the situation has been in flux as to how these things are going to be consented and how they're going to be granted. And there are lots of different processes like EIAs, appropriate assessments and things like that that are being done. And this, using a risk-based approach, has to fit in with these existing processes so that it doesn't become an added layer of complexity or an additional task. There was also a feeling that direct evidence of risk-based approaches in action for wave energy devices would be very useful. And really that they felt they needed this in order to feel confident that they can engage and understand the benefits. And seeing them working particularly in another jurisdiction would be a real incentive to consider using the approach further. So I think what this shows is that we need more of these devices to be allowed and to be consented in order to keep gathering the information to make risk-based approaches feasible and to build confidence in them. And finally, I suppose we asked them what kind of effects were they most concerned about, and what came out strongly was the cumulative effects were seen as presenting a significant difficulty in general to consenting processes, and anything that could help with this would be really welcome. So I think that's a summary. I'm happy to take any questions along with Iban, and yeah, that's it for me. Thank you.
Well, I'm supposed to keep track of time, right? And we have 2 minutes and 1 question, so it seems definitely feasible. We have a question for you, Iban. I don't know if you could read it. Thanks for the presentation. Did the risk assessment consider opportunities to share space with existing renewable infrastructures such as wind farms, or is that resolution too small?
Consider that at this stage, the potential co-location or coexistence of different activities with wave farms in this case was not considered in our models, which is interesting. Yes.
And I don't think we have any other question. Any question for Emma or Ivan? Oh, there is one coming in.
Yes, in the other chat.
As a surfer, I've realized most coastal projects of different natures do oops, not that easy to read. Sorry. Do not realize how delicate and vulnerable a wave is and the sensibility for surfing. I was considering whether you have considered this activity in this research, and what are your thoughts about it?
Understood properly.
Well, I guess it's co-location with other activities such as
Yes.
surfing, but it's not only and the impact and renewable energies could have on waves.
No, we didn't take into consideration. For example, surfing was not considered in our approach. I have to say that what we did, it was we collected information that is available from publicly available data sources like EMODnet, for example, and at that stage we didn't have that information. And in fact, another thing to consider is that, for example, the relationship between ecosystem components and the pressures were like side pressures. I mean, we were not considering the spreading of the pressures, and this would be an example on how the pressure is produced in the farm and how it is being spread to surrounding areas. So surfing, for example, is a good example how the extraction of energy in a farm can affect those more coastal zones in which surfing is being conducted. But as we saw with Pedro's survey, yes.
Yeah, and there are interesting publications, I think, on the the dissipation of wave from wave energy devices from Central Nantes, for instance, from a few years ago. Maybe Pedro, do you have an answer on this?
If I can jump in on this, in all of the results we got in the project, meaning the impact on waves, the energy extracted in a wave farm, and it reflects on the coast. So the energy that is extracted is in the order of magnitude of the error of the measurements and of the natural variability at the sites. So it really doesn't impact surf in the study in terms of the waves that were studied and the devices that were studied in this project. And usually it's like that for most of wave energy devices. Okay, so the energy extracted is in the order of the magnitude of the natural variability of waves in surfing sites. There may be some different things,
but it's one in the work of the marine dynamics modelization, we have obtained these results. So in this sense, surfing somehow has been addressed. I mean, there was a worry about if these wave harms can affect the coastal zone, and as you said, the impact is quite. I am not a specialist in marine dynamics. It's quite local. So we don't see impact over the coast. Okay, so in that sense, I think that surfing is not going to be affected, at least with these results. But
yeah, if you have a link to send, perhaps a link to a deliverable or something to put in the chat would be nice. And as you asked me to keep time, we have to go on the next presentation. We like to answer questions, that's the thing, but there's more to show you. So here we go. I think it's Niall's turn.
Yes, it's my turn, and I'm going to talk about public engagement and education with respect to renewable energy marine environment. So my name is Niall Dunphy, and I'm from University College Cork. And hopefully you can see my slides. So deployment of marine renewable energies really has the potential to evoke opposition. And in many cases, it leads to social mobilization, which has on the land and is increasingly in the marine environment. It's obstructing the realization of specific developments. It's hindering the expansion of renewables. Current strategies for education and public engagement have not been successful. They really are very top-down. And the communication is very unidirectional, and it's just not responsive to local circumstances and local concerns. So there's a knowledge gap, skills gap concerning how we can meaningfully and effectively engage the public on marine renewables. And this needs to be addressed in order to increase the acceptability and thereby the acceptance of proposed marine renewable energy deployments such as wave energy. So when we talk about education and public engagement, there really are, I suppose, there's three reasons why we should engage the public. First, there's the normative idea. It's the idea that it's the right thing to do, that these projects should involve all individuals who have a stake in the decision, who are impacted by the decision. Secondly, there's the substantive idea, the belief that involving the public in this way will improve the decision-making by incorporating diverse knowledge into the decision-making process. And thirdly, and probably quite commonly, it's used instrumentally. It's used as a tool in order to achieve a specific goal. This may be to increase acceptance or foster trust, or simply because you're obliged to do it through regulations or permitting. So within SafeWAVE, we've worked to develop and trial an effective framework for education and public engagement in the marine renewable energy context. The initial step was to develop a better understanding of societal response to wave energy. And this was carried out through a systemic literature review and a structured media analysis, including looking at social media. Arising for this, we found out that the sources of opposition include conflicts with existing users, threats to jobs, impacts to local communities and traditions and activities, including, of course, surfing, impacts to ecosystem components, noise, and other environmental impacts. So your typical economic, social, and environmental aspects. They're very often considered really as an add-on to the technical components of a project. And there's these non-technical barriers to deployment that have such an impact. Our next piece of work in this area was to undertake a critical review of selected education and public engagement programs associated with marine renewable energy and infrastructure deployments. Some information on selected case studies was gathered through a literature review and interviews with key informants. And the method used for education and public engagement in each of these cases was analysed. Key challenges that were faced were identified, best practices documented, and the developed knowledge then fed into the creation of a framework for education and public engagement, which we used within the project. So many of the sites we used were involved in the project itself, and others were in close by locations that we could access people and information on. I suppose the lessons from this really is the importance of early engagement of all stakeholders, and this is meaningful engagement with them. The engagement of key informants and thought leaders is vital, and this, I suppose, emphasizes that it's a two-way communication. We also found that the use of both informal and formal means of communication have a role to play in building trust, and in particular to be responsive to community concerns and community issues when they arise in the community. The way in which a project is framed is very important, and it can increase, for example, place-based distinctiveness, which in many cases was important in building a sense of pride in the deployment of renewables in a local area. Design flexibility, of course, is an important determinant of the social acceptability. And we found that, very often communities were wondering what's in it for us. And in this way, that hiring local population, particularly at the early stage of engagement, is an important factor in building trust, both in terms of that they're talking to people they know, that they trust, but also that the communities can see themselves that there are some benefits for the community for being involved in this project. So next I'm going to talk identification and characterization of societal stakeholders. So this involved a review of what constitutes stakeholders and the characterization of the societal context in 5 test sites of interest in Spain, Portugal, France, and Ireland. The sites were described, a description was created of the communities, the political context analysed, relevant public agencies and authorities identified and characterised, water users identified, and again, this includes recreational users. And this is, I suppose, where users such as surfers, for example, but also fishers and the various other water users who both use it economically and recreationally are very important. Thought leaders and other relevant actors. So in doing this, we identified who are the key players in a particular location. So this characterization informed work on the framework for education and public engagement, and eventually it fed into the development of ocean literacy orientated public engagement programs, which are developed for each of those countries. So informed by this work that I've just described and drawing from multiple disciplines, from sociology, psychology, political science, education, but right across the range of disciplines, a general approach for education and public engagement was developed. And then working with stakeholders, and particularly the community-based stakeholders, this general approach was specified as an EP framework for ocean literacy and ocean energy acceptability programs. And the output of this was a documented a methodological approach for the creation of tailored EPE programs for individual energy projects with a focus on wave energy. So we use this framework for education and public engagement then as the basis for developing tailored education and public engagement programs for each of the 4 focal countries, France, Ireland, Portugal, and Spain. The programs were designed to raise awareness of radio energy transition, climate action, through outreach, education, and training initiatives, but also to provide an inclusive mechanism for community and wider society stakeholders to input into planning and realization of ocean energy projects. This was just some examples of the types of activities that are useful in this approach. Consulting the public, it's always useful to have a virtual presence, whether it's web or social media or the various ways people engage with each other. Media content, information campaigns, school programs, demonstration activities, all of these are very, very useful to, I suppose, reach out to the public and to consult with them. We want to collaborate with the public, so in other words, involve them more. Polls, surveys, questionnaires, focus groups. Specific forums, for example, water user forums, public meetings, similar dialogue sessions, or collaboration clinics can be quite useful. And then moving forward a little bit more, maybe to co-creation. We can have web learning sites, community education training initiatives, citizen science activities, summer programs, open access material, and so forth. So there's a number of ways in which we can engage the public to different levels and for different objectives. So key elements of the programs that were developed for France, Ireland, Portugal, and Spain were trialed and evaluated. The findings reinforced the importance of engaging early with societal stakeholders and engaging in a meaningful way, in a way that's seen to be meaningful, seen to be respectful. Identifying people to act as community liaisons, people who are of the community and in the community, and are seen to be not working for outsiders. Fostering respect and transparency and striving for both inclusivity and diversity in the people that we engage with. And then it was very important to be seen as a collaboration with and for the community, and not just a checkbox exercise or a means of gathering data. So if we follow these 4 principles of engaging the public, they go a long way for the most important aspect, which is building, maintaining, and nurturing trust with communities. And I suppose this is the hardest thing. And once we lose trust with communities, it takes a lot of effort to try and rebuild it. So as part of this work, we've identified some guiding principles for effective education and public engagement. It should be reflexively planned. It should make a difference to participants in their community. Facilitate open and interactive spaces for learning. Foster respect and transparency. As we mentioned already, strive to be both inclusive and diverse in the people that we engage. Have a flexible design, be seen as a collaborative partnership, working for the common good. Encourage actionable dialogue, designed to meet measurable goals, and ideally the outcome of this should be a co-created plan for action, that the community are working with the developers to produce this co-created plan. Working with the communities, we developed some key performance indicators based on these guiding principles, and it was these KPIs that we used then to assess the various activities that were implemented in the 4 focal countries. So just some challenges then in realizing effective EPE. There is public distrust of developers of all sorts, and that includes those developing marine renewable energy. There's also a distrust of the public by developers, so the trust is not just one way. There's budgetary limits, so ideally we'd like to do quite an expansive program of public engagement. It's not always possible or practical. It's going to be time constraints, both statutory time constraints within the planning process, but then also time constraints for the program. There's disinterest and apathy among much of the public. So how do you engage with them? There's disparate and potentially conflicting interests of different publics. So different components of the public will have different priorities, will have different concerns and issues. So how do we address that? There's a lack of capacity and capabilities among most of the companies in this area. And increasingly we see that there's a lack of institutional knowledge from project to project. So once a project is done, there's a lot of institutional knowledge has been built up and engaged in the public on this, but by the time the next project comes and we have all these different actors coming together again, a lot of that institutional knowledge is lost, and that's a real shame. And finally, we're living in the age of disinformation, misinformation, and malinformation, and this is no less an issue in the area of renewable energy and marine renewable energy, and it's very difficult to address this. It's a challenging issue, but it's one that we must bear in mind when we're engaging the public. Thank you for your attention.
Thank you very much, Niall. Thomas, we have...
Yeah, I think we have one question, but it's somehow an internal question, but I can read it anyway. Which is the best method to be used in initial community engagement? In your opinion, who would be a legitimate player in the deployment of marine renewable energy? I guess a legitimate player in the EPE programs, I guess.
Yeah, it depends on the community. It depends on the experience of the community. So many of the communities that we will be engaging with in this work have already played host to various deployments of infrastructure, will have experiences, good, bad, and indifferent. So we must be informed by that. So somebody who might well be a trusted player in another community will be seen as not so trusted in that community. So it really is a case of understanding the community that you're engaging with, getting to know them, and on that basis then working with them to see the best way to engage with them and communicate with them.
And I think the next question that just popped in is linked to this. In my opinion, did you find that there were substantial differences between countries in effective engagement strategies? Were there specific strategies that worked globally?
There are some countries, and I won't name them, but there are some countries where public agencies are trusted and are seen as trusted sources of information, are seen as being neutral players, are seen as being for the public good. In other countries, due to the cultural context and historical experiences, maybe these public bodies are not so trusted. So you can imagine in the first group of countries that having a public agency very much involved in reaching out to the public on an issue would be a positive thing, and definitely would not be so positive in other countries. But again, it's about specifying the program to the circumstances of the community. You're muted, Thomas.
Sorry, yeah, the question was about a global strategy, but I would say that we wrote down deliverables on a methodology, right, more than a strategy. Would you agree with this, Niall? We suggest a methodology to work EPE programs more than a strategy, which is a bit different. Is that correct?
It is in that the methodology, I suppose, describes how you would produce a strategy for any given time and place. So there's a methodology which is documented, which is in the reports that are on the website that has previously been posted, and that methodology outlines how you specify the approach for a particular case. So again, this is why we talk about a framework approach.
Yeah, as I said, it's in the work package 7. And I sent the link again. And I think it's time, right? There's no more questions, I think. So Juan, back to you.
Let's see more questions. Before I go ahead with the final remarks, Iñaki de Santiago from ASTI sent us by WhatsApp because unfortunately he's not here due to personal last-minute problems. But he responded us about the wave reduction, to the question of Ian Farley about the validation of the modeled wave reduction. And he said, I agree. Yes, we use past data from buoys, from depth to coast, and check with current wave propagation, and the model fit perfectly. Then afterwards, they introduced 16 weeks. We introduced 16 weeks in the model, but the outputs could not be validated because this 16 device doesn't exist. But the base was validated. I understand. This is only a small tip before going ahead with the last presentation. So I'm going to share once again. Okay, do you see my screen?
Yes, Juan.
Okay. So it's time for the last final remarks and a summary and conclusion and path forward. So regarding the environmental research strategy, I think that in general, considering all the assumptions and limitations of explained it before, the results that we have obtained in the monitoring and modeling task has allowed us to improve the knowledge about the environmental impacts coming from these wave energy developments and consequently reduce this uncertainty about these environmental impacts. And we have shared all this information in Maritime data. This better knowledge and reducing uncertainty fits directly the risk-based approach and the Maritime Spatial Planning tools that we have developed in the consented and planning strategy, because they provide us a better knowledge about the likelihood, consequences, and magnitude of these impacts, and give us the opportunity to better assess this risk. This risk-based approach and these tools are strongly linked. In some way, the tools that we have developed, in some way they operationalize or they make especially explicit this risk-based approach. And also these tools contribute to this risk-based approach because these tools give us the opportunity to better assess this environmental risk or these environmental impacts. And finally, all these acknowledge that we have developed tools, risk-based approach, reducing uncertainty, and so on, has been the information base, the basis for the development of these EPA programs that we have tested in different countries. So in general, I think that it's true that the project has, in my opinion, has achieved the main objective of the project and the secondary objectives, which was to contribute to overcoming these non-technological barriers. But of course, like in all projects, there are still some aspects that remain or that are subject to further research. As you can see, we have developed this monitoring or this environmental research around single devices, most of them prototypes in test facilities. These test facilities, they have played a key role in this research, because most of this industry is at the beginning, and most of the deployments they are deployed in test facilities. So the key role of the role of these test centers, test facilities, is very, very important. But what happens if we move from single to larger arrays? So when we start to move from single to larger arrays, we will need a deeper understanding of this environmental, but also the social and economic effects of these larger arrays. At the same time, it has been quite difficult also to match the timeline of our research project, which depends usually on the deadline of the funding card, with the timeline of the developers. The developers, they are focused on demonstrating the technology. They go to the test facilities and start the test. And then we come with our research project and we try to match both timelines. And sometimes it's not easy. So I think that we need to include the environmental research since the beginning in the developer's perspective and timeline. And developers need funding calls that not only support the technological development and demonstration, but also pay attention to these environmental aspects. So, because in this environmental research of underwater noise, electromagnetic fields, marine dynamics, aggregating effect, change in habitats, we need, as has been said before, longer monitoring periods. We need to measure during high power production, which is the same to say in strong sea states. So if we want to have longer monitoring periods and monitor during strong sea states, we need to move from classical monitoring in single and specific campaigns to remote sensing, able to monitor during longer periods and in these sea status that are very, very difficult, because these deployments are deployed in places where we have enough wave resource. Regarding consenting and planning, it has been said before, we need in these tools and risk-based approaches, we need to integrate other technologies, not only those that we have considered in this project. We need to consider other technologies. We need to include additional knowledge of environmental impacts if we move from single to large arrays. We need also to pay attention to cumulative pressures. And coming from the public engagement research, it is very interesting, very important to include also in these tools the social and economic aspects of these deployments. And finally, regarding the public engagement strategy, in my view, this strategy could be a single research project by itself. This is something that has been new from WESE to SafeWAVE. And well, I think that it remains still, even if we have developed these EPA programs and we have tested in different countries, I think that we also need public to be better informed. We need to be better informed about the public. We need develop public engagement capabilities, outreach, education, and training initiatives to engage from the beginning, and so on. Nair has explained it much better than me. But I think that in this research strategy, we have still lots of things to do. And from my side, in my opinion, it could be a single research project by itself in the future. So I would like to finish to explain my acknowledgements to CINEA for co-funding this project. Without this co-funding, this would be not possible. So thank you. I would like to acknowledge the European Union through CINEA agency. I also want to acknowledge ETIP, Ocean, and LOTA for giving us this opportunity to explain this project in this session and for hosting this session. And on behalf of all the team of the SafeWAVE project, I cannot mention each of them. Hope to not miss anyone. Only I would like to thank you, the attendees, for being here and for being interested in this project. As we have said, and Lotta said, the recording of this meeting will be available. The deliverables of the project are available in the SafeWAVE website. We are close to the end. We are just ending during this month of November the last deliverables. So I guess that during December, all of them will be achieved and ready and available in the SafeWAVE website. So if you want to go deeper on that, you can go there, or you can contact us. You have our emails, and so feel free to contact with any one of the SafeWAVE project or with me. So thank you very much for your attention, and that's all. I don't know, Lotta, if you want also to close or to say something.
No, just to say thank you very much for the presentation. Thank you to all panelists, and congratulations on carrying out this really important project. And I hope to see further projects going forward after this one. So with that, I wish everyone a nice rest of the day and see you soon. Bye.
Thank you.